So today we're looking at solving compound inequalities. And so simply put, a compound inequality means that we're going to be looking at uh, two or more inequalities. Up to this point, we've solved single step with multiplication and division, and we solved single step with addition, subtraction. We solved multi-step, which feels a lot like solving a regular equation. And today, we're going to add to that by actually solving two inequalities at one time, and we're considering them together. The two different kinds that we'll do, one will have the word and in it, and they'll have to be solved and graphed a certain way. And then or problems or compound inequalities have to be solved a certain way. So let's take a look at the first kind here. And again, a compound inequality simply means that we've got two inequalities and we're going to consider them at the same time. We're going to solve them and graph them on the same number line. Okay? Compound inequalities with and are solved by finding the intersection. Okay, so and intersection, they go together. And inequality means we're looking for an intersection. And I know what you're asking. Intersection means we're looking for an overlap. Okay, so when we look at the number line, we'll be looking for an overlap between the shadings of the two inequalities. So here's one and inequality, and you'll recognize it because it says and. Right, we have one inequality and a second inequality. So this is a compound inequality, and we're going to treat it like an and because it says it's an and. Now there's two different types of and inequalities, and we'll see the other one next. But this is one way that you'll see an and we simply solve both inequalities. Okay, so adding 3 to both sides, y is greater than -8, and adding 3 to both sides, y is less than or equal to -5. Okay, and okay, we're going to graph both of these inequalities on the same number line, and that combined graph will be the solution set. So here we go. Let's take a number line here. Let's take another number line here. And now notice we want -5 and -8 to be on our number line. And so let's just put right here in between them. So -8 is going to be back here somewhere. -5 is going to be on this side. Right, so you've got -4 keeps going this way. We kind of know what numbers are in between 5 and 8. -9 would be back here. And that's just for reference to make sure we've got our number line going in the right direction. And so y greater than or equal to -8 would be right here, and it would shade right in this direction, and it would shade all the way right greater than -8. Okay, less than or equal to -5 right here, it would shade in this direction. Okay, now my solution, and I think you can see this, my solution is the overlap. Okay, so my solution is, and let's get us a new number line down here where we can put our solution on it. So here we go. On our solution number line, we have -8 and we have -5. And our solution, the overlap, starts at -8 and starts at -5. And it's all the stuff in between. That's the overlap. Okay, so if you look up, you'll notice that -8 and to the right, -5 and to the left, and this is the part that overlaps, and so that is our solution. Okay, now to write this in actual solution form, okay, let's go ahead and pull everything off the number line, and we're going to say, and actually for now, let's just leave it here. For this one, we can leave that is our solution, and this is our graph. Okay, let's go and look at the second type of and the thing that makes this one a little more interesting is the fact that we we said all at once, and there's no and, but it's all together. Okay, so you're going to be tempted, after we look at the or, you're going to be tempted to make the or look this way. Ors don't look this way, only ands look this way. Only an and compound inequality can be written all together like this. Okay, now to solve an and that's all together this way, and you'll remember the rule, if I do something to one side of an equation or an inequality, I have to do it to both sides. Well, in this case, you have to consider the fact that you've actually got three sides, right? So in the middle here, we're trying to get the variable all by itself here in the middle, and what we do to the middle, we also have to do to these two sides of the inequalities. Okay, you'll see what I mean, and then I'll give you a chance to do one. So I think it's pretty clear that we've got to add 3 in the middle, and that's going to get the variable by itself. But that means I've got to add 3 here and add 3 here, right? So what I'm doing to one side of the inequality, I'm doing to all sides of the compound inequality. So that's going to get x all by itself, and 4 plus 3 gives us 7, minus 2 plus 3 gives us 1, and we didn't do anything to change the direction of our inequality, and so we just literally bring down the less than or equal to on that side and the less than on this side. And so we read this as -1 is less than or equal to x is less than 7. Okay, now these are a lot easier to graph, simply because they kind of give you the entire formula all in one place, and it says that x is going to be between 1 and 7. And so on my number line, here's 1, here's 7, and so my solution is going to so equal to, less than or equal to, so that's going to be a solid dot. This one is just a less than, so it's going to be an open dot, and the x is between the 1 and the 7, and so I shade between the 1 and the 7, and that's my solution. So these are a little easier to solve when they're all together, but we solve them the same way as we do the and that split it to two pieces. We graph them a little differently. These are a little easier to graph, but we're still looking for an overlap. And says overlap. Okay, so that's what we're looking for. All right, so let's see if you try one and see what happens here. Show me your solution and then do your number line. So there's nothing to change the direction, so I'm going to go ahead and drop the inequalities down. Subtracting 7 here in the middle is going to get r all by itself, and then we've just got to remember to subtract 7 on both sides. And so -1 less than or equal to r less than 3, and then that number line, -1 less than or equal to r is going to be in the middle, 3 is going to be on this side. It's an open circle because it's not the or equal to, and that's what that number line should look like. Okay, so let's go ahead and look at or inequalities. And again, compound says that we're doing two inequalities and we're doing them at the same time. Or inequalities are solved by finding the union of two inequalities, and that simply means that we're going to put together. Union means we're going to put together. So where the and, we had to specifically have an overlap. With an or, we're just going to take a single number line and we're going to put both of those solutions together. Whatever happens, we're going to put it together, and that graph will be our solution. So here's an or. They're always going to be separate. You're not going to see an or that's all in one place like this one was. Okay, or is always going to be separate. So here we go. Solve them separately. Subtracting 1 from both sides. A is less than 4. Or adding 1 to both sides. A is greater than or equal to, excuse me, I didn't actually subtract my 1. Alright, hold on just a second. There we go. Subtracting 1 from both sides. A is less than 3. or A is, adding 1 to both sides, A is greater than or equal to 4. So union or says put them together. So here's my number line. Here is 3. Here is 4. Make sure they're in the right spot on your number line. And here we go. If I'm less than 3, then I shade this way. If I'm greater than or equal to 4, I shade this way. And then this is my answer. That's my answer. And then this is my my number line, my shading. You'll notice with an or that we will often have arrows going in opposite directions, and that's okay. That's okay, because what we're saying is that our solution must be true for this inequality or that inequality. So that's why the shading sometimes looks separate, because there's several different places I can pull an answer from. All right, now this one is a little more complicated, but in the sense that it's just a multi-step, you should still be able to solve this one. So this one's yours, this is an or, and this one's yours. All right. So we're adding 7 to both, subtracting 7 from both sides. We are dividing by -2, which is going to flip our direction. Okay, so that one is solved. And then we are subtracting 12 again. Not again, we're subtracting 12. And then we're dividing by +5, so nothing flips. Okay, now both of these ended up being greater thans. That's fine. We got an or in between them, and so this is, for all practical purposes, that's our solution. Let's go ahead and look at what the number line looks like. And so -3 would be somewhere over here. 5 would be somewhere over here. All right, we'll change color so we can see what's happening with our shading. And here we go. We are greater than or equal to -3. And so that's going to shade this way. And we are greater than 5. So open circle and shade this way. And now you'll notice that this does actually overlap, but I'm not concerned about the overlap. I'm just concerned that both solutions to the inequalities were graphed on the same line. And so if you'll notice though, looking at our number line, actually m greater than or equal to -3 really kind of covers everything. Okay, so I'm not worried about us recognizing that just yet as far as writing an answer down, but I do want us to see that that's what happens sometimes. Okay, now one more, and we'll see what happens here. Okay, so it looks like one side is already solved for us. Okay, so let's solve the other one by, let's see, subtracting 2 from both sides and then dividing both sides by 4. Okay, so here we go. X is less than or equal to 9, or X is less than 2. Number line, here's 2, here's 9. Okay, so less than or equal to is going to go here and to the left. Less than 2 is here and to the left. And so again, it really looks like just the one inequality gave us everything we were looking at. But for now, we're okay identifying this entire solution as our answer. Okay.